Welcome to Part 5 of Applied Chemistry, where we will explore petroleum, its composition, and the process of fractional distillation. Throughout this section, we will examine the chemical makeup of petroleum and the various fractions obtained through distillation. Let's get started. Petroleum, also known as crude oil, is a naturally occurring liquid found beneath the Earth's surface. It consists of a complex mixture of hydrocarbons, along with small amounts of sulfur, nitrogen, oxygen, and trace metals. Over millions of years, petroleum forms from the remains of ancient marine organisms, which have been subjected to heat and pressure deep within the Earth. Petroleum is composed mainly of three types of hydrocarbons. Alkanes, paraffins, these are saturated hydrocarbons with single bonds between carbon atoms. They typically exist in the lighter fractions like gasoline. Cycloalkanes, naphthenes, these are cyclic hydrocarbons with single bonds, forming ring-like structures. They're found in the heavier fractions such as kerosene and diesel. Aromatics, these hydrocarbons contain one or more benzene rings. Aromatics are used in the production of chemicals like plastics and synthetic fibers. Additionally, petroleum contains small amounts of sulfur, nitrogen, oxygen, and metals, which can impact the refining process and result in the formation of pollutants during combustion. Fractional distillation is the process used to separate crude oil into different components based on their boiling points. Each fraction contains a mixture of hydrocarbons of similar molecular weight and boiling point range, which are then refined further for specific uses. Fractional distillation is the key process in petroleum refining. Here are the main steps. Heating of crude oil. The crude oil is heated to around 350 to 400 degrees Celsius, causing it to vaporize. Entering the distillation column, the vaporized crude is introduced into a tall fractionating column. The temperature is hotter at the bottom and cooler at the top. Separation of fractions. As the vapor rises, it cools, and different hydrocarbons condense at various heights, depending on their boiling points. Heavier hydrocarbons condense near the bottom, while lighter ones condense near the top. Collection of fractions. Each fraction is drawn off at different points in the column, corresponding to its boiling range. You can better understand how fractional distillation of petroleum works through this diagram that shows how the process works and how different fractions are obtained at different temperatures. The major fractions obtained through fractional distillation include gasoline, boiling range from 40 to 205 degrees Celsius, used as fuel for internal combustion engines. Kerosene, boiling range from 150 to 275 degrees Celsius, used in jet fuel, domestic heating, and lamps. Diesel, boiling range from 250 to 350 degrees Celsius, used in trucks, buses, and heavy machinery. Fuel oil, boiling range from 300 to 600 degrees Celsius, used for power generation and industrial heating. Lubricating oil, boiling range from 400 to 600 degrees Celsius, used as lubricants for machinery and motor oils. Residue, bitumen or asphalt, boiling range above 600 degrees Celsius, used in road surfacing and roofing. Fractional distillation is critical for refining petroleum efficiently. It allows for the efficient use of crude oil by separating it into different fractions, maximizing its utility. Tailored fuel properties. The distinct properties of each fraction make them ideal for specific applications, such as gasoline for engines and kerosene for jet fuel. Feedstock for petrochemicals. Many of these fractions serve as essential feedstocks for producing chemicals, plastics, and other industrial products. In summary, petroleum is a complex mixture of hydrocarbons, primarily composed of alkanes, cycloalkanes, and aromatics, along with small amounts of sulfur, nitrogen, and metals. Fractional distillation is a vital process in refining petroleum. It separates crude oil into different fractions, each with specific uses in fuels, lubricants, and industrial applications. This process ensures the efficient and versatile use of crude oil to produce everything from gasoline to asphalt. We've reached the end of our detailed exploration and covered different topics in this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on applied chemistry and other exciting topics.